see me and hear me. Okay, so I've just slightly changed the settings. I'm just using a different laptop. Okay, so sorry for the technical delay. Okay, so anyways, so we'll just get started. Okay, so today's class. Okay, so welcome to today's class. Okay, happy evening. So I'll just quickly respond to your messages. Okay, and then we can get going. Okay, so Priyanka, Dia, Tanisha, Deeksha, Aparna, Samruddhi, Sneha, Sri Krishna, Shravana, Pranamya, then Sri Gauri, Amok, Yash, Vinayak, then Shreyas, Rashmi, Anmol, Shaurya, Ashish, Kunal, Amaya, Shraddha, Manoj. So everyone, so good evening all. Okay, so good evening all. Okay, so yes, today we'll start the class. Okay, so with the video that I showed you yesterday. Okay, that is what happened. Okay, to the Tesla Roadster. Okay, so is it still orbiting the moon or something happened to the car? Okay, so let us see the answer. Okay, so to this question about the Tesla car in the Mars. Okay, and then we will start the chapter that is atoms and molecules.
We've sent a lot of unusual things to space. Guitars, AI robots, even a golden record. But
space, and once we have the technology to reach Mars, okay, so then you can definitely see where exactly, okay, the car is. Okay, and as they tell, okay, so you can even see the car in the telescope after a few years maybe. Okay, so that is what, okay, so that is what the video is about. Okay, so with this, okay, we'll get started. Okay, so with the car, or not with the car. Okay, we'll get started with atoms and molecules. Okay, so anyways, so this is a new chapter. Okay, so going back to chemistry. So I'm going to take up a new page. Okay, so yes, atoms and molecules. How many of you, okay, how many of you have already completed this chapter in your school? Okay, you can click on the yes icon if this chapter is already finished in your school. Okay, if it is not yet completed in your school, then you can click on the no icon. Okay, if it is already completed, you have finished this chapter, okay, then you can click on the yes icon. Okay, so that I have an idea how many of you have finished it and how many of you have not yet finished it. Okay, if the chapter is going on in between, sir, in my school also same chapter teacher is doing, then you click on thumbs up. Okay, so if you think that in the same chapter is going on in your school, okay, then you can click on thumbs up. Okay, if it is already completed, then click on yes. If it is not completed, then click on no. Okay, so anyways, so some of you have completed, some of you haven't completed, and some of you have this chapter still going on in your school. So anyways, so not at all an issue. Okay, so I'll just continue. Okay, so with the chapter atoms and molecules. Okay, so the first thing you need to know is that atom is the fundamental unit of matter. Okay, so if you remember about cell, okay, cell is a fundamental unit of dash. Okay, so can you tell me what is the dash? Okay, cell is a fundamental unit of life. Okay, so in the same way, atom is the fundamental unit of matter. Okay, so atom is the fundamental unit of matter. Okay, so the next important thing, okay, so you're supposed to know is about this. So in the previous chemistry chapter, so we learned about the pure substances. So we will see more about these pure substances. Okay, so In the previous chapter, so we saw about mixtures as well as the pure substances. Okay, so we will see in detail about these pure substances, which you can classify into two categories. Okay, so one is elements and another is compounds. Okay, so these are the two categories, okay, so in which you can classify the pure substances, okay, that is elements and compounds. Okay, and if you remember, so I had told about the elements, okay, so that it consists of same type of atoms. Okay, it consists of same type of atoms. So what do I mean by this statement? What do I mean by this statement is that if I take an iron rod, okay, if I take an iron rod, so the iron rod will have only iron atoms. Okay, the iron rod will only have iron atoms. Iron rod will not have gold atoms. Okay, iron rod should have iron atoms. Okay, so if I take silver, okay, if I take silver spoon, okay, if I take silver spoon, silver spoons will have dash atoms. Okay, silver spoon will have dash atoms. Okay, so fill in the blanks. Okay, silver spoon will have silver atoms. Okay, that's all. Okay, so the elements, they have same type of atoms. Okay, so that is your definition. So I'll give here an example. Okay, so silver spoon has silver atoms. Okay, so gold or necklace will have gold atoms. Okay, so because they are made up of, silver is made up of silver atoms. Okay, the silver spoon is made up of silver atoms. Okay, so this is about the elements. Okay, so this is about the elements. Okay, so now Kunal is asking about the plastic cup. Okay, so you must have learned. Okay, so plastic cup is not a pure substance according to science. Okay, so the plastic, okay, is made up of a synthetic. Okay, so you must have learned in 8th standard. Okay, so if you remember, okay, so that is made up of your synthetic materials. Okay, so we don't consider that under the category of your elements. Okay, so elements are those, okay, so which you can see in the periodic table. Okay, so if you are not aware of periodic table, then I'll show you the periodic table. Okay, so according to science, according to chemistry, okay, all the elements, okay, that we are aware of, so we have put it in this table called periodic table. Okay, so I'll just show you. So this is your periodic table. Okay, so comprising of 118 elements. Okay, so the periodic table has 118 elements. Okay, so how many of you have seen this periodic table, or how many of you know about this periodic table? You can click on the yes icon somewhere in the textbook, okay, or somewhere in the in your school. Okay, so charts. Okay, so you had seen the periodic table. Okay, so this is your periodic table. Okay, so comprising of 118 elements. Okay, so if you carefully see, okay, so these are the 118 elements. Okay, it is properly organized with a logic. Okay, so with a logic. Okay, so the way it is arranged, there is a reason for that. Okay, so there's a reason for that. You need not by heart or remember any of this, because you will anyway learn in detail. Okay, so in your 10th standard as well as in your 11th standard and 12th standard for sure. Okay, so now, so we are just getting to know about our pure substances, that is elements and compounds. Okay, so over here, okay, so I'm just gonna, okay, so use the symbol, okay, for silver. Okay, the silver symbol is Ag. Okay, so this is your definition about the element. Okay, so now heading towards the compound. Okay, so let us see. So what exactly is the definition of a compound? Okay, so in the compound, so it consists of different types of atoms. Okay, so in compounds, okay, so it consists of different types of atoms. Okay, so what is an example? Okay, so I'll take a simple example. Okay, so that is water. Okay, so your water has a formula. Okay, so all the pure substances have a formula. Please remember. Okay, so if the substance is not having formula, then we don't call it as a pure substance. Okay, so all the pure substances, okay, so they have formula. Okay, so just keep in your mind. Okay, keep in your mind. Okay, so I'll just write here about the water. Okay, so water, it has atoms of hydrogen and oxygen. Okay, so you see in the water comprises of hydrogen and water. Sorry, hydrogen and oxygen. Okay, so because in the water molecule, you have both hydrogen atom, okay, as well as your oxygen atom. Okay, so that is the reason why in the formula you write H2O. Okay, you write H2O. All of us know that. Okay, but why not HO2? Okay, why only H2O? Why not HO2? Yeah, why not H2O2? Okay, so uh, what do you think? Okay, which is the correct formula? Okay, so we always write water as H2O. So everything, so we have a reason. Okay, we have a reason. Okay, we have an explanation for that. Okay, all of this we will learn in this chapter, atoms and molecules. Okay, so why do we write it in a particular way? Okay, so the formula, the terms, the chemical symbols. Okay, so all of this, so we will learn in the chapter atoms and molecules. Okay, so this is just about the definition part. Okay, so the pure substances, that is elements and compounds. Elements have same type of atoms, so compounds have different types of atoms. Okay, so example, elements, I've just taken it as silver. Okay, whereas for compound, so we wrote water. Okay, the compound, the example is water. Okay, so now the next thing, so I will just quickly mention here. Okay, so about the important one, so that is the law of chemical combinations. Okay, so before that, I'll just quickly write a few points. Okay, so Indian and Greek philosophers they had few ideas. Okay, so about the matter. Okay, but nothing could be proved scientifically, because in science we need proof. Okay, without proof we don't accept things. Okay, so all these Indian and Greek philosophers, they just had ideas. Okay, but they could not prove the idea scientifically. Okay, so I'm just going to write few things. Okay, so about this, had always wondered about matter and framed few ideas or theories. Okay, so they had few ideas or theories, but unfortunately we couldn't, prove it scientifically. Okay, so or if they had proved scientifically, the proof was missing. Okay, the proof was missing. So we have this great Indian philosopher. Okay, so who had given us, in somewhere in the scriptures it is written about the Parmanu. Okay, but we couldn't agree on that, because we just need to have the proof. Okay, the science works in that way. Without proof nothing is agreed. Okay, so I'll just write about this Paramanu. Okay, so which is in the 500 BC or something. Okay, there's this Maharishi. Okay, so Maharishi Kannad. Okay, or hey, not Kannada, man. Okay, so it is Maharishi Kannad. Okay, so had this idea of divisibility of matter. Okay, so as I told you, it was just an idea. Okay, so you have to prove it. If you cannot prove it, then we cannot accept it. Okay, so idea of divisibility of matter. Okay, so this was just an idea. Okay, but moving forward, many millions of, not millions, so many hundreds of years later, okay, so we had this scientific proof. Okay, so we had scientific experiments. Okay, and we consider them as the real the idea. Okay, so that was your laws of chemical combination. Laws of chemical combination. Okay, so put forward, okay, by this chemist called Lavoisier. Okay, so Lavoisier put forward this laws of chemical combinations which could be proved according to science, and then we accept it. Okay, so without proof we don't accept, with proof we accept. Okay, so this was put forward by Antonio Lavoisier. Okay, so what are these laws of chemical combination? Okay, so we will see that laws of chemical combinations, so one by one. Okay, so first of all, I would like to show you one amazing reaction, because chemistry is full of amazing reactions. Okay, so what are those reactions? I just going to show you, okay, something wonderful. Okay, so yesterday I showed you one reaction, so I have like many more to show you.
Welcome to the wonderful world of chemistry. Today, with the help of the colorful chemistry set by Mel Chemistry, we will obtain a magic liquid which changes colors depending on its pH. Perform this experiment on the plastic tray to contain any possible spills. Don't forget to put on protective gloves and goggles before doing the experiment. To open a bottle containing a reagent, push the cap down and turn it. Pierce the bottle nozzle with an unbent paper clip. For the magic liquid experiment, you will
experiment or in this activity, so do not worry if you did not understand much. Okay, so I just wanted you to look at the output. Okay, so you see that different colors, okay, different colors of liquids is obtained. Okay, because the solution indicates the presence of an acid or a base with the help of a color change. Okay, so I hope you have learned in your 7th standard or in 8th standard about the acids and bases. Okay, so you will again learn them in 10th standard. Okay, so but I just wanted to show you, okay, the chemical reactions are beautiful and colorful. Okay, so you will get some amazing products. Okay, so when a chemical reaction takes place, okay, you should know what type of chemical reactions to do. Okay, so I'll be showing some more wonderful chemical reactions throughout the chapter. Okay, so the first law of chemical combination, okay, is related to the reaction. Okay, so what does it tell? So I will write it down. Okay, the first law of chemical combination, that is law of conservation of mass. Okay, so first I'll write the statement, so then I'll explain to you what exactly is this. So law of conservation of mass. Okay, so what does it tell you is that, okay, so the mass is neither created nor destroyed in a chemical reaction. So I'll write it here. Mass is neither created. Mass is neither created nor destroyed in a chemical reaction. In a chemical reaction. Okay, so what is the understanding that you can have from this statement is that, so I will write the interpretation also. Okay, so this tells me about the total mass of the reactants, the total mass of the reactants is equal to the total mass of products. So what is this? Okay, so I'm going to explain, okay, in the next couple of minutes. Okay, so notice carefully, okay, so what I'm going to write now. So I will take an example and explain. Okay, so suppose there is a chemical reaction taking place. Okay, so chemical reaction is taking place. So I have my substances A plus B. Okay, so A plus B comes together, it reacts. Okay, A plus B reacts to form C and D. Okay, so we call this A plus B as reactants. So what are these reactants? Okay, so these reactants are the substances which react with each other during a chemical reaction. So during a chemical reaction. Okay, so what exactly is this? Okay, the substances, okay, so which react with each other during a chemical reactions, you call that as reactants. Okay, so then what is C plus D? Okay, so what is the C and D? Okay, the C and D, okay, so you call the C and D as products. Okay, so the C and D, okay, so these are the products. Okay, so what do you mean by products? Okay, the products are the substances, okay, so which a new substances, okay, so which are formed after a chemical reaction. Okay, so these are the new substances formed after a chemical reaction. Okay, so this is your products. Okay, so products are the substances which are formed after a chemical reaction. Okay, so all you have to remember is reactants are the substances which react, okay, during a chemical reaction. Products are the new substances. Products are the new substances which are formed after a chemical reaction. Okay, now, so let me check if you understood this, terminology or not. Okay, so what I'll do is that I will write one reaction. Okay, I will write, let me see if you can tell me answer to this question. Okay, what are my reactants? Okay, so what are my reactants in this example that I have written down? Okay, so what are my reactants? Okay, so very nice. Okay, so very nice. All of you are telling correctly. Okay, so fantastic. So over here, okay, so my reactants are nothing but the hydrogen, okay, the hydrogen and chlorine. Okay, so hydrogen gas represented as H2. Okay, so chlorine gas represented as Cl2. Okay, don't worry about the symbols. We will learn about the symbols in this chapter itself. Okay, and then what is the product? Okay, what is the product? Okay, so my product is HCl. Okay, so this is my hydrochloric gas. Okay, this is a gas. Okay, so please understand, I'll write the states also. This is gas, and this is also a gas. Okay, so hydrogen gas reacting with chlorine gas to form hydrochloric gas. Okay, the acid, hydrochloric acid, is different. Okay, hydrochloric acid, so we represent hydrochloric acid like this. Okay, so hydrochloric acid, you have to take this hydrochloric gas, hydrogen chloride gas, and dissolve it in water so that you can have the hydrochloric acid. Okay, hydrochloric acid is different. Okay, so over here, so what we have is this hydrogen chloride. Okay, so what we have here is HCl gas. Okay, hydrogen chloride gas. Okay, so which is my product. Okay, so which is my product in this case. Okay, so do not worry about the numbers and all which I have written. So that we will learn in this chapter later about the balancing and all that. So we will learn later. So do not worry. I just wanted you to understand about the reactants and the products. Okay, one more example. One more. Let me see if this example, if you can tell me the answer. Okay, one more simple and easy reaction. Okay, so in this case, okay, so what is my reactant and what is my product? Okay, what is my reactant and what is my product? Okay, so very nice. Okay, as most of you, okay, told correctly. Okay, so these are my reactants: magnesium and oxygen. Okay, magnesium and oxygen. So these are the reactants. And what is my product? My product is magnesium oxide. Okay, the product I have is magnesium oxide. Okay, so over here I should mention the states like this. Okay, magnesium is solid, oxygen is gas. Okay, and the magnesium oxide what I got, okay, so that is solid. Okay, so this is okay, so this is how you represent. Okay, you should know the reactants and you should know the products. Okay, so going back to our law. Okay, the law says mass is neither created nor destroyed in a chemical reaction. Okay, so that means the total mass of the reactants is equal to total mass of the products. Okay, so remember the word total. Okay, total mass of the reactants is equal to total mass of the products. Okay, what is this? So again, let me take one simple example. Okay, so over here, I will take an example to tell you about this. Okay, so just a example. So suppose, okay, suppose I have assume 10 grams of A. Okay, so 10 grams of A reacted with 2 grams of B. Okay, just an example, assume. Okay, 10 grams of A reacted with 2 grams of B. Okay, so now I got 6 grams of C. Okay, I got 6 grams of C. What do you think? How much will be the mass of D? Okay, how much do you think is the mass of D? Okay, so very nice. So all of you are telling me the correct answer. Okay, so this is only your law of conservation of mass. Okay, so over here, as you can see, okay, the total mass. Okay, so total mass of reactants. Total mass of reactants. So what you should type here? So 10 plus 2. So that is 12 grams. Okay, so total mass of reactants is 12 grams. So what is total mass of products? Okay, total mass of products is nothing but 6 plus X. Okay, so we know that total mass of reactants is equal to total mass of products. How? As per our law of conservation of mass. Okay, as the mass is neither created nor destroyed. Mass is neither created nor destroyed. So what should we write here is that, okay, the total mass of reactants is equal to total mass of products. Okay, so the total mass of reactants is equal to the total mass of products. Okay, so I have to write here 12 is equal to 6 plus x. So if I solve for x, I will get the answer. Okay, so that is 6 gram. That's all. Okay, so if you understood this, okay, if you understood this law, you can click on the yes icon. Okay, if you understood this law, that is law of conservation of mass, okay, you can click on the yes icon. So very simple, so very easy. All you have to do, okay, so is just, okay, analyze your reactants and the products. Okay, so count. Okay, so count how much is your total mass of the reactants and how much is your total mass of products. Okay, you have to equate them. Total mass of reactants is always equal to total mass of products. Okay, very nice. So this was one of the dummy example. Okay, now real example. Okay, so let us take one simple real example. So let me see if you can find the answer to this example. Okay, so what is the example? Okay, the most famous example all of you should be knowing about. So that is your water. Okay, so formation of water. Okay, so I will write here my reaction. So if I tell you that I took 4 gram, okay, I took 4 gram of hydrogen, assume, okay, and 32 gram of oxygen, how much will be my water? Okay, so what will be the mass of the water? Okay, so this is the question. Okay, so you have to calculate and you should tell me. So what will be the mass of the water as the product formed? Okay, so if you carefully do the calculation, then you will get to know the answer. Okay, so again, so you should write here according to law of conservation of mass. Okay, so according to law of conservation of mass, so I have to see, okay, so what exactly is happening. According to law of conservation of mass, total mass of reactants is equal to total mass of products. Okay, so what is the total mass of reactants? That is 4 plus 32 is equal to x. Okay, so then what will be my x? So x will be 36 gram over, that's all. Okay, so this is your law of conservation of mass. Okay, so in the exam also, so you will get like very simple and easy questions. Okay, so before I show you the question, okay, from the textbook, okay, I will first make you see this video and then we'll go for the question.
Today, I decided to forgive you, not because you apologized.
Okay, so we will learn about this law of constant proportion next. Okay, so the first one is what I wanted you to understand. Okay, that is law of conservation of mass. Okay, the total mass of the reactants is always going to be equal to the total mass of products. Okay, only this much if you know, that is more than sufficient. Okay, so now what we'll do is that I will show you the real question from the textbook. Okay, let us see if you can answer this question. Okay, so what is the question? So I'm gonna show you the question. Okay, so I want you to solve the question number 1. Okay, so your in-text question. Okay, so you can see here. Okay, the in-text question. In a reaction, okay, 5.3 gram of sodium carbonate reacted? Okay, so that question, okay, so we will solve now. Okay, so how to do this? So first we should write our reaction. Okay, so I will take my notepad and I will share my screen. Okay, so this is even in-text question. So I'll mention here that is in-text question. In-text question. Okay, so what was the question? Okay, the question was 1. Question number 1. Okay, so I will show you the question and let us try to write it down. Okay. So over here, so look at the question. Okay, so understand the question first, very important. Okay, so they are telling that in a reaction, okay, so 5.3 gram of sodium carbonate reacted with 6 gram of ethanoic acid. Okay, so 5.3 gram of sodium carbonate reacted with 6 gram of ethanoic acid. So I am gonna write it over here. Sodium carbonate, okay, reacted with, so I'll write neatly, sodium carbonate reacted with ethanoic acid. Okay, so how much? That weight also I will write. So 5.3 gram. So reacted with 6 gram, okay, of ethanoic acid. Okay, the products were, I'm going to write the products. The products were carbon dioxide plus, okay, water, carbon dioxide plus water, and there was another product that is sodium ethanoate. Okay, plus sodium ethanoate. Okay, so this is the reaction. Okay, so they themselves have told here. Okay, so show that the observations are in agreement with the law of conservation of mass. Okay, so I will also write the weight, I'll write the mass. Okay, so I'll write the mass of all this. Okay, the carbon dioxide 2.2 gram. Okay, so water 0.9 gram. Okay, and the sodium ethanoate. Okay, so how much is that? 8.2 gram. Okay, so this is your reaction. Okay, so just for your information, okay, so I will just write it down in terms of chemical symbols. Okay, so sodium carbonate has the formula like this. Okay, ethanoic acid is like this. Okay, so this is your ethanoic acid, CH3COOH. Okay, is your ethanoic acid. Okay, so giving you the products carbon dioxide, water, and sodium ethanoate. So CH3COONA. Okay, this is how your reaction will take place. Okay, so another name for ethanoic acid is acetic acid itself. Okay, the ethanoic acid, if you take 8% volume by volume, then you call it as the acetic acid. Okay, so another name, the common name you should be aware of, that is vinegar. Okay, vinegar, acetic acid, ethanoic acid, everything same. Okay, so just another few terms. Okay, so do not worry about the symbols, okay, in the form of reactions, so that you will learn in your 10th standard. Okay, in the 10th standard, you will learn how to write the reaction, how to balance the equation, everything you're gonna learn in your 10th standard. Okay, so now I just wrote it, okay, just for your information. Okay, so this is your 8.2 gram. So water is 0.9 gram and carbon dioxide is 2.2 gram. Okay, so you have to prove, okay, prove law of conservation of mass. Okay, so how do you prove this? So what should you do? Okay, so what should you do? So they have given the data, they have given the reaction, they have given the masses. Okay, so what should you do? Okay, absolutely correct. You just have to show, okay, you just have to show that the total mass of the reactants is equal to total mass of the products. Remember the word total, very, very important word. Okay, so we will solve here according to our answer. Okay, the law of conservation of mass says that mass is neither created nor destroyed in a chemical reaction. Okay, so that means the total mass of the products, sorry, the total mass of the reactants, is equal to the total mass of products. Okay, so what does this indicate? So I just have to write here 5.3 plus 6 is equal to 2.2 plus 0.9 plus 8.2. Okay, we can see that this is equal to 11.3 gram. Okay, over here, if I see 2.2 plus 0.9 is 3.1 plus 8.2. So 8 plus 3, 11. Okay, then 0.1 plus 0.2 is definitely over 11.3. Okay, so we can see here that LHS is equal to RHS. Hence proved. Okay, so just like your mathematics. Okay, so this shows that the law of conservation of mass is validated. Okay, so in the reaction, it agrees to the law of conservation of mass. Every reaction should agree to the law of conservation of mass compulsory. If it doesn't agree, then that means you have written a wrong reaction. Okay, so they are correct, you have made a mistake. Don't tell that the law is wrong. Law is correct, we are wrong. Okay, so you should write the reaction properly and you should add everything properly without making mistake. Okay, so this was your law of conservation of mass. Okay, so very simple, very easy. I'll just start the law of constant proportion. Okay, but we will do that in tomorrow's class. Okay, so I will just write the statement, that's all. Okay, I won't do anything much. Okay, I'll write the statement, but we will continue about this in the next class. Okay, so I'll just mention about the second law. Okay, that is law of constant proportion. Okay, law of constant proportion. So what is this law of constant proportion? So as the name indicates, you must have got a clue over there. Okay, but if you did not understand, so no problem. So tomorrow's class, okay, so we'll discuss in detail about the second law of chemical combination. So that is law of constant proportion. Okay, so it says that in a chemical substance, okay, so in a chemical substance, TANCE, the elements combine in a definite ratio or in a definite proportion. Okay, so what is the meaning of the statement? So we'll see in tomorrow's class. Okay, so in a chemical substance, the elements always present, or you can just say it as combine in a definite ratio, or you can also tell it as proportion or proportion by mass. Okay, so this is important. Okay, so here you need to understand that in a chemical substance, okay, the elements always is present or they will combine, okay, so in a definite ratio by mass. Okay, so what exactly is this? So we're going to see that in tomorrow's, we're going to see this in tomorrow's class. Okay, so now, so real quick, okay, I'm going to show you the game pin. Okay, so you can enter the game pin and join the quiz. Okay, so what is the quiz? Okay, the quiz is about today's class. Okay, so basically just an introduction, okay, to your chemistry, just to check how much you know about your chemistry. Okay, so on your screen now, I'm going to show you the game pin. You can enter this game pin and join the quiz. So quickly type www.kahoot.it. Okay, and on your screen now, I'm going to show the game pin. Okay, so there you go. This is the game pin. I hope you can see it on your screen now. Okay, you can enter this game pin and join the quiz. Okay, so very nice. So that was the quiz. Okay, third position we have Sneha. So second position, so we have Amaya. Okay, and the winner of today's quiz is none other than Yash. Okay, so congratulations everyone. Fourth position Sanskriti. So fifth position Samruddhi. Also congratulations to all those who got all questions correct. Okay, so that's been my time. So thank you so much for staying back. Okay, and playing the quiz. So see you again tomorrow. Bye bye.